The first challenge of Mr. Steal Your Crypto is Jpeg Sniper. This video will be a walkthrough of this challenge, how to solve this challenge. This challenge is based on NFT marketplace called Hopex, which is launching a NFT collection called Booty. This marketplace contains a wrapper contract which handles the public sale mint of for this particular collection called Booty, and the task is to bypass their safeguards and max mint the entire collection in single transaction. Let's look into the contracts. There are 3 contracts, and I have already copied these contracts to my VS Code. I'll be using Foundry to test the contracts and write the exploit using the Solidity. The first contract is the wrapper contract, second one is the base contract, third one is not a contract, it's a file which contains predefined errors. In the wrapper contract, we have 2 different functions. One calculates the current phase of the public sale, whether it started or not, through calculating the timestamp. The second one is the public sale minting, which mints the NFTs for the users during the public sale. Whatever quantity the user gives, those many quantity of NFTs are minted, but certain conditions have to be met before minting. There is a modifier called at phase, which takes in the phase and checks the phase of the public sale. In the base contract, we have internal functions, number minted, which returns number of NFTs minted by the specific address, total supply is returned, and then there is a min for user function. It's an internal function which mints the NFTs for user, and then there is a refund if over function which calculates the extra tokens and refunds the message.value if it exceeds to the user itself. Looking into the contract itself, there is this public sale mint which can be accessed once this contract is deployed. While deploying, there are a few variables are initialized, which are collection size, max batch size, and number of tokens address can mint during this public sale. There are a few conditions which have to be met, as I told before. The caller of this public sale function should be a EOA, not a contract, and the public sale has to be started, which is checked by @phase modifier. The third condition is the sum of quantity, which is input, and the number of tokens minted by the message.sender should not be greater than max per address during mint, which is initialized during the deployment of the contract. The next condition is total supply, and the sum of total supply and the quantity shouldn't exceed the collection size. Collection size over here is the number of NFTs, and once that is done, the total price is calculated, which is sale price multiplied with the quantity, but the sale price is 0 because in base contract it is not set, and it is commented that it is free mint, so the price will be 0, and therefore the total amount will always be 0. Once this calculation is done, user will be minted the NFTs, and if there is any extra tokens, then it will be sent back to the user itself through refund if over. The thing is, like, this contract is trying to make the user only to able to mint a certain number of tokens, uh, which is set by max per address during mint. But the vulnerability over here is a user can send the minted tokens to a secondary address and then again call this function. Through this, he can pass all these conditions and then mint again. As we know, only EOA can call this. EOA over here is uh, which is not a contract address, uh, and the code size of that address shouldn't be more than 0. Like it shouldn't be exceeding 0, which is calculated by this modifier which is present in base contract. So let's look into the exploit which I have developed. I've written a attack contract which contains only constructor because code size during the deployment of a contract is 0. So any functions called in constructor can be executed, and through this we can pass is EOA modifier. First I'm assigning the owner and then instantiating the contract at the given address, which the given address and the owner over here, which is the attacker itself, are the arguments of the constructor. After that, I am declaring a variable to track the token IDs, and then setting the setting two variables which will store the max batch size and collection size. The scenario over here, the attack scenario over here uh, is that public sale has started, which means the contract has been deployed. The collection size over here is 69, max batch size is 5, and address can mint 5 tokens during the public sale. And attacker is deploying this attack contract. So basically, once the deployment has started, the exploit is also started. The finally verifying whether the balance of the attacker on a number of NFTs present with attacker should be the total amount of NFTs which can be minted is, which is over here is 69, the collection size, and the total supply should be 69. These two conditions has to be met to complete this challenge. So as I told, a user can send the minted NFTs to a secondary address again and again call back the public sale mint. So basically, I have implemented that over here. Through a while loop, I'm checking whether the total supply is less than the collection size, which is 69. And if this is met, then this loop runs. Once that is started, then I'm making a condition where the sum of batch size and the total supply uh, should like if it is greater than the collection size, then I'll be reducing the quantity of uh, tokens should be minted, or else it can be the same amount, the same batch size, which is 5. Now once if this condition is met, then we'll be decrementing the batch size. But in the first few loops, this won't happen, so this condition will not be satisfying, and then we'll be moving to the next instruction, which is to which is to mint the tokens. Over here, we are passing the quantity, which is 5, and once the uh, NFTs are minted, the owner of those five NFTs is this contract. So we now have to transfer those tokens to the secondary address. The secondary address I'm using here is the owner, which is the attacker. So I'm keeping track of the token IDs which has to be transferred through this loop and then transferring it to owner. After that, I am updating the token IDs since we have minted 5. Now the token ID will be 5 and the starting one will be 0. So in the first loop of this will be like 0, 1, 2, 3, 4 tokens would have been minted and be transferred to the attacker, and then token ID will be updated, and which is I is equal to 5. In the next loop of while, the token ID will start with 5, and this loop goes on until every token is minted by this address or else by this contract, and then transferred it to the attacker. Let's look into the exploit. I've written it in Solidity. I'm using Foundry to test. So this is the command to test the exploit. Okay, since all the conditions which we have set over here have been met, test result has been okay and passed. So this exploit is working. The problem over here was because of the function called number minted, which is present in base contract. Basically, it returns the balance of the number of NFTs minted by a specific address. This can be changed if that particular address is sending those NFTs to a secondary address which they own. Due to this, a user can call this public sale mint function multiple times and drain or like take the ownership of all NFTs. This was the first challenge and it was really interesting. I'll be posting walkthroughs of next challenges. If you want to look into the exploit more, I'll be putting this into the GitHub, and I'll link the GitHub in the description.